Okay, very good. So, hello everybody. Thank you, Lee and Anthony, for inviting me to this session today. It's an honor to me to participate in any kind of community-related activity. I was chatting with Lee earlier that community really changed my professional career. So I encourage you to keep participating and moving on any activity related to community. The session today is performance features in SQL Server and Azure features. This is a topic that I love. I've been working with SQL Server since many years ago. So a little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as an IT director in the DBA and BI Services at Mediterranean Shipping Company. And I've been working with SQL Server and the data platform stack for more than 25 years. So I have started working with SQL Server 6.0. I'm Microsoft MVP in the data platform category since 2016. I'm also Microsoft certified trainer. I am member of the board of advisors of the Azure Data Tech community, and I define myself also as a technical speaker. I've been part of the PASS community since 2008, I believe. So I have participated in a bunch of events as attendee and as a speaker. Down here in Argentina, I'm one of the organizers of the SQL Argentina group. We used to have our monthly in-person event, now switched to virtual, hoping to resume it to in person at some point during next year. But in the meantime, we just meet virtually. I have over there also my contact information, email address, LinkedIn, Twitter, and my blog. If you have any questions about this particular presentation or any other thing that you would like to discuss, or if you just only want to do networking, feel free to ping me over there. So let's start about talking SQL Server performance and in SQL Server and Azure SQL, right? So first of all, before starting, the idea is to understand a little bit what is this Azure SQL, right? This is a new naming convention, a new terminology, or what is Azure SQL in reality? I define this like a new kind of umbrella in where we can put several products and services related to SQL Server, right? There are 4 components that are members of the Azure SQL family, right? The most recent one, which is Azure SQL Database Edge, right? We won't be covering it today. By the way, Azure SQL Database Edge is the one that allows you to run SQL Server on an ARM device, like for example, a Raspberry Pi or any kind of sensor using an ARM processor. Right? We won't be covering that one. That was the latest addition to the Azure SQL Database family. So we're going to be covering the other 3 members of this family. Azure SQL Server per se, running on virtual machines, managed instance, and Azure SQL Database, right? If we go further a little bit and also to understand a little bit more about the history of SQL Server and what will be the scope of this session, right? We can see that, here in this slide, we have since SQL Server 2008, as I said, there are few more before 2008. But in reality, the idea is to focus on the ones that Microsoft calls the modern version of SQL Server, which are 2016, 17, and 19, right? As you know, Microsoft has announced SQL Server 2022 recently. A lot of excitement around during the PASS Data Community Summit a couple of weeks ago. There were a lot of announcements related to this new version. So we are really looking forward to start playing around with the community technical preview version so we can start validating our workloads on this new upcoming version, right? But today, as I said, we're going to be focusing on Azure SQL, right? SQL Server running on virtual machines, managed instance, Azure SQL Database, and the modern versions of SQL Server, 16, 17, and 19. So this is Azure SQL, the three main components, right? Azure SQL or SQL Server running on Azure virtual machines. Well, this is what we know, right? The product that we've been working kind of forever, but running at the top of a virtual machine pre-configured in Azure. And this is what Microsoft called infrastructure as a service, in where you as an end user or a DBA or as an administrator, you have to take care of the whole infrastructure behind the SQL Server. For example, your SQL Server will be running on an operating system that is running on a virtual machine. So you have to take care of the operating system, the patching, etc. For example, if you have to do backups, if you have to set up high availability and disaster recovery, those are things that you have to handle yourself, right? Not only the SQL Server configuration, maintenance, etc., but also the infrastructure behind. Then there are another two components, right, of the Azure SQL family, which are managed instance and Azure SQL databases. These two members of the family are known as into the bucket called platform as a service, in where you only have to handle and manage and use the SQL Server component. You don't care, you don't know what is behind that SQL Server in terms of infrastructure, right? You don't know which kind of OS it's running, you don't know much, right? But what you know is that Microsoft offers you a service level agreement, right? It's offered you with a SQL Server endpoint in where you just connect, deploy your user databases, and have your own application, right? In terms of patching, in terms of high availability, disaster recovery, including also the backups, right? You don't have to worry about it because Microsoft will do it for you as part of the services. And why we have two components, managed instance and Azure SQL Database, right? That's one of the important points to cover here. Well, Azure SQL Database is one of the very first services that was presented when Azure came alive more than 10 years ago, 12 years ago, if I remember correctly, right? This is a SQL Server-like engine, right? In where the main, let's say, characteristic that you have here is that all your application or your deployment has to live within a single user database. For example, if you have a legacy application which has a store procedure, which is joining tables that are located in multiple or different user databases. Well, you cannot use it with Azure SQL database, right? You have to re-engineer your database, your application to be able to use Azure SQL database. It's quite powerful for certain things, but definitely the target is more like focused for modern applications or new applications. Instead, if you want to do a lift and shift of your SQL Server databases to something almost 100% compatible with SQL Server, right? In where all the T-SQL language plus the features plus everything is what you know, but with the benefit of the platform as a service thing, with I mentioned earlier, right? Like automatic patching, automatic backup, high availability, disaster recovery out of the box, etc. You have to use managed instance, right? So, as for today, SQL
Javier,
Server. Yes.
This is Lee. I have a question.
Yeah.
So, can you go back one slide?
Yeah, absolutely.
So, in my company right now, I'm getting into a bit of Azure, but we're primarily on AWS and EC2. Mm-hmm. And some of the struggle I'm having is that I'm having to manage a lot of hardware choices and a lot of storage choices. Mm-hmm. And I'm just wondering what that's like in Azure virtual machines. Is it a similar thing where you create an Azure virtual machine and you still have these different range of instance types and different varieties of storage that you have to combine? Can you talk a little bit about that?
Yeah. Well, when you create a virtual machine, I'm not very familiar with the AWS offering, right? But I do with Azure. When you create your virtual machine, yes, you have to deal with a bunch of things, bunch of settings. For example, the first thing that you get is this marketplace. We can go quickly later if you want, and I show you. But you have in the marketplace several images in where you have a bunch of combination of operating system, right? SQL Server version and edition. So you can start your image from a SQL Server 2008 R2 running on Windows Server 2008, right? Hopefully nobody's using that, but eventually if you need it, it's there, up to a SQL Server 2019 running on Windows Server 2019, right? So, but then, yes, in terms of the important thing is that when you do the initial setup, you know that most of the best practices that Microsoft has for SQL Server, they will come pre-configured when you deploy this virtual machine. For example, the storage, the 10 DB settings, a bunch of other things related to the accounts, etc. They will come directly when you do the setup. But then you have to have certain, knowledge on how to configure the disk, the IOPS, the throughput, right? Then you have, memory, virtual cores. You can, do your own combination. But yes, it's not, you can start with a very basic VM and then eventually do a scale up, right? But yes, you have to have certain knowledge, right? All the knowledge that we carry from, let's say, SQL Server best practices, etc., most of them still fit, but there are some new rules that apply on when you are defining this kind of virtual machines in Azure, right? It's more specifically in terms of storage. Mm-hmm. I will show you in later when we reach that part. Mm-hmm.
Okay, thank you. Appreciate it.
Sure. So as for today, SQL Server runs kind of everywhere, right? It's not when I started back in the 90s, you have SQL Server running on Windows Server, period, nothing else. Today, you have the possibility of running SQL Server on a Windows machine, on a virtual machine, on a bare metal server or virtualized, right, on a Windows platform. But also, you know that since SQL Server 2017, you have the possibility of running it on the major Linux distributions like SUSE, Red Hat, or Ubuntu, right? So that was a game changer. Since then, also you have the possibility of running SQL Server in containers, right? And if you want to, let's say, do an environment based on containers for ready for production with more choices for high availability, etc., you can also use SQL Server running containers on Kubernetes, right? At the same time, and as we mentioned before, we have this Azure SQL virtual machine, managed instance, Azure SQL database, and finally the Azure SQL Edge, right, which again runs on ARM devices, right? So almost everywhere. Then, we have this. I always like this slide to emphasize on the benefits of Azure SQL, specifically the options which are platform as a service or PASS, right? A few weeks back, when we had the PASS Data Community Summit, I was listening to Brent Ozard keynote, and there was this phrase that definitely defines a lot. He said, the cloud exists because we suck on capacity planning. Right? So when we have to define, the specification for a virtual machine in terms of horsepower, right? We suck on that, right? And this is the main benefit of, any cloud computer solution. In this case, Azure, right? Scalability, right? You can scale up and down dynamically, manually, any way you need to. Right? Eventually, if you notice that after monitoring that your virtual machine is, high on CPU usage all the time, and you may need to jump to another VM with additional virtual cores and additional memory, and maybe with faster disk, this is a matter of few clicks, right? So definitely scalability is one of the most important thing in any of the Azure SQL components, right? It's also important to know this concept that, because there is this misconception that you can say, since I'm running in Azure, I won't have any problem with my virtual machines. So no, that is totally false, right? If you set up a virtual machine, right? If you set up a service over there, you have to take care of setting up, for example, the disaster recovery, as you do on-prem, right? If you have an environment running SQL Server on-prem, you need to set up the window cluster, the availability groups, put the databases, everything that you need to take care in your on-premise environment. If you do this on virtual machines, you have to do it also in Azure. But instead, if you use managed instance or Azure SQL Database, platform as a service, you have the business continuity, high availability, automated backup, long-term backup retention. This is extremely important because, for example, we all struggle when we need to take our backups. And, if you are trying to certify for a specific, ISO certification, you have to store your backups on a different location than where it's taken, etc. Well, all that you can do it directly in Azure, right? You can have your, component in an Azure region and replicate those backups to a different region. So this way, you are compliant with those rules related to backups, right? As I mentioned earlier, scalability, one of the most important things in this cloud era. And now also something that I like to emphasize a lot is that Azure SQL, managed instance and Azure SQL database is what Microsoft called versionless. What does it mean? If you connect to managed instance or Azure SQL database, you will see that you see Azure SQL as a version. You don't see SQL Server 6.0, 7, 2000, 2008. You know that in the past, when you have to deal with an upgrade from one version to another, you have to revalidate your whole application from one version to the other. What Microsoft is telling us with this version is that we don't need to worry about the version number anymore. This is Azure SQL period, right? No numbers, no different versions. Does it mean that Microsoft is not doing any innovation managed instance or Azure SQL DB because the versions are not changing? Absolutely not. Actually, it's the other way around. They just go with the new features and enhancements on managed instance and Azure SQL database, and then they bring the power of those features to SQL Server for the next or the upcoming SQL Server version, right? So those are important things that I like to emphasize before going deeper into the performance area, right? So now we're going to start with that. And for the ones that we've been dealing with SQL Server for years, when we are talking about performance capabilities, we always talking about the same. Before, now, and probably in the future, we need to take care of these three main pillars of any SQL Server environment, which are processing, right, CPUs, memory, right, and storage, I/O. Those are the three major things that we have to take care. Then, we can go deeper into indexing, best practices on how to allocate files or another thing, but specifically, we need to take care of these three main components. That's not changing. So the idea is to see with Azure SQL and with the modern versions of SQL Server 2016, what we can do in order to help the engine and accomplish this performance. So
Javier, this is
yes.
Lincoln. I have a quick question. So in
Yes,
managed instance, we get the essentially the enterprise edition of SQL Server, correct? There's no more distinction once we get into managed instance between standard and enterprise. Is that correct?
Yes, there is no enterprise, no standard, no developer. It's Azure SQL Database Managed Instance or Azure SQL Database. What you have over there is what Microsoft called service tier, right? Which is, in the case of managed instance, which is the one that is more similar to SQL Server, right? You have two tiers, two main tiers. One is business critical and general purpose, right? The only difference that you have between one or the other is that the disk for the business critical has less latency because there are locals, and there is an additional read-only replica for your workload. In terms of features, I mean, what we know from SQL Server, the standard versus enterprise, in where you can, for example, use compression or not, or column store, etc. That thing doesn't exist in Azure SQL Database or managed instance, right? The service tier is what is you will be choosing in order to support your databases at the top of this engine, right? And again, you can switch between them eventually. This is the scale up or down, right? But yes, in terms of what we used to know with the standard enterprise developer, web edition, or whatever, that doesn't fit anymore in this new model.
Okay, thanks.
So, sure. So monitoring and troubleshooting is a really important thing for us, the DBA, something that we really need to take care of. Anthony was saying earlier that it's not fun or it's not fancy, whatever. I do love doing performance monitoring and troubleshooting on SQL Server. I believe it's fascinating, and just being able to tune queries to make sure that engines run faster, that the code run faster in this is really good. And also Microsoft definitely is helping us with the latest features, and those are the ones that we're going to be checking right now. Oh, here we go. So these are the features that we're going to be talking specifically on the SQL Server modern version, right? First of all, Querystore, right? Querystore is a fascinating feature that was basically a game changer in the overall performance history here. Then at the top of Querystore, presented in 2017, automatic query tuning. We're going to talk about this. Adaptive query processing in 2017, that then was rebranded or changed it to be intelligent query processing. And then we're going to be talking about the changes that were introduced in 2019 for the 10 DB metadata. So what is this main concept of intelligent database or intelligent performance? Well, we're going to have a component within our user databases, right, that will be somehow checking what's going on in terms of performance, runtime statistics, etc. And if eventually it detects any anomaly, any change or something that needs to be adjusted, right, it will either notify us or make that change itself, right? So that is the concept of intelligent performance, right? And the very first feature to accomplish that was Querystore. Again, introduced back in SQL Server 2016. This is basically like a flight recorder of our queries in our user database. What is that? What does it mean? Okay, you know that when you have a query, right, the first time that it runs, it will compile, it's going to come up with a plan, and then it will be reusing that plan, right, to the upcoming execution. Well, with Querystore, what we're going to have is in our user database, when we enable Querystore, we're going to have this repository where for each query in our user database, right, that is running, we're going to have the plan, the multiple plans that it may have over time. That a plan on a specific procedure can change, right? Sometimes not for the best. Sometimes when it changes, it could even have a regression. And then, within Querystore, beside the changes on the query plans, right, we can have all the runtime statistics. So how many times it was executed, that particular query ID or statement, right? The minimum amount of time, maximum, average, resource usage, etc. So everything is captured on this performance repository called Querystore, right? Then we will see that from Management Studio, we will be able to access all this information and do a bunch of things. Besides understanding what is going on, which are the heaviest processes within the user databases, right? We can also do some good stuff with that. So, as I said before, SQL Server, first of all, it compiled the plan, and asynchronously it will store that plan, right, in this repository. Then after getting the plan, it will execute that query using the plan, and we're going to get the runtime statistic, and everything will be stored in this repository, right? It's quite easy to enable Querystore on a user database. Pay attention on this. It's not per instance, it's per user database that you have to enable Querystore, right? Something to mention here is that for managed instance or for Azure SQL database, when you create a brand new database, right, Querystore will be enabled by default. In SQL Server 2016, 17, or 19, when you create a new database, Querystore will be disabled by default. So eventually, if you want to use it, you have to enable it manually from Management Studio or using another database statement. Microsoft has announced that in SQL Server 2022, they will mimic the behavior of Azure SQL Database and Managed Instance. So when you create a new database, Querystore will be enabled by default, right? So there are multiple scenarios to use Querystore, right? All of them related to performance. You want to see if the plan has regressions, which are the heaviest execution in terms of resources, which are the ones that are taking longer than the others. Eventually, if you are migrating from a SQL Server version from one version to the other, you can use this to see if with the new cardinal estimation you will have any regressions, right? Because you can easily get it from Querystore, right? Something also important to mention is that with Querystore, right, you will have the ability of, if in a case you find that a particular query ID has a regression, meaning that the new plan is not good, or the previous one was better than the one that is using right now, so now it's taking longer, it's using more resources, etc. You will have the ability of manually forcing, right, a specific query ID to use a previous plan. So this way you force the plan and you make the performance to be more stable. What is the idea of this set of features? Basically, to help you not only to have your queries running faster, it's trying to help you to make your queries to be stable, meaning doesn't matter if the server is idle or if the server is really busy, try to have a stable performance of your queries, right? You know that in previous SQL Server version, you may have a report or something that normally runs in 10 minutes, and suddenly somehow it's taking hours and you don't know what's going on or why, and nobody has changed anything, right? Those kind of regression, those kind of things are what have been trying to be addressed with all these features, right? And the first one is, as I said here, Querystore, right? So how do we access the Querystore information? Well, from Management Studio, we will have the possibility of having certain reports that will show us a bunch of things, like, for example, the top resource consuming query, right? And very easily we can see which are the queries that are taking more resources, right? And then from the user interface or using this SQL commands, we can force or unforce a plan for a specific query ID. We will see it in action in a minute, right? Here, there are a set of best practices for Querystore, right? If you use it in a heavily loaded transactional environment, there may be some trade flags that is going to be good to have, right? So because this one has certain performance penalty, it's not too much and definitely, you know, it works to consume that, you know, set of resources, because the benefit that you get with this is really, really good, right? So remember, for Querystore, you know, you will have this performance repository database in where you will be able to see everything, right? Again, we will see it in a second. In SQL Server 2017, at the top of Querystore, what Microsoft added was the possibility of, you know, in Querystore, if there, let's say there was a regression, or if Querystore detects a regression, it can automatically, right, adjust the behavior to use the last known query plan. That means if there is a regression, immediately the regression will be fixed using a previous well-known good plan, right? And the performance will be back to how it was before, right? In Querystore 2016, initially, you had to access this data from the repository and then manually fix the plan, right? That means if the regression happened at 3 a.m. in the morning and there is nobody checking this, well, someone's going to be checking in at 8, 9 a.m. in the morning and doing the fix over there. With automatic query tuning, if the regression happened at 3 a.m., 4 a.m. in the morning, and nobody is there, automatically, right, it will adjust to the last known good plan, and the performance will be back to how it was, right? Definitely a great feature, a game changing at the top of Querystore. So in Azure SQL, the big difference here is that, as I said, you have all this enabled by default, but there is something additional in Azure SQL Database, which is automatic index management, right? In Azure SQL Database, you have the ability of course, if you enable and if you want to use it, right? You have the ability of have automatic index management. That means if the engine detects that your queries, your workloads requires a new index, right, it can create it on the fly, right? What does it mean, right? This is something checking if your query requires an index, it will automatically create that index. And then if that index is not in use anymore for any reason, it can eventually drop it, right? So we will see it in a minute, but definitely really interesting feature, right? Because
yeah, that's wow.
Yeah, it's I mean, for a DBA, an old school DBA like me, this is kind of strange. I don't want nobody just creating indexes for me. But definitely I can say that I'm being quite surprised with how it behaves, right? It's really good for certain you know, use cases, but at least you have the possibility. And you know, if you don't have that expertise on how to create wrap indexes or these kind of things, well, the engine can do it for you, right?
Javier, this is Lee. Just a quick question about that. Is it creating those indexes online?
Yeah.
Okay.
Yeah. You can configure on the point of the day, or maybe when you know, there are less amount of resource being used, but yes, you can tell it when and how to create it, but the final decision will be, you can put some input there, but Azure SQL Database will be the one doing it for you, right? as I said, it behaves quite well. And yes, the index is created online. I've seen some cases in where this index creation, like any other index creation, may enter some blocking situation for some time, but definitely the decision that it takes when creating these indexes are really, really, really good. So this automatic tuning, right? Automatic query tuning is not a one-time thing, right? That, you know, the plan changed, the new plan is not good, and it just set the last one and work is down. No, completely wrong. This is constant, right? It will learn based on the Querystore information in this repository. Eventually, if there is a problem, it will adapt or adjust the behavior and will keep verifying if the new behavior or the new, you know, or the changes are really good. And if they do, right, it will apply it. And then this will be a cycling option because it will happen continuously, right? So we all know what the plan regression is, and this is for the case that I said at the beginning, in where, you know, you have this procedure that normally takes certain amount of minutes, and one day the plan changed and it's not good, so it starts taking forever, right? So, you know, before we had to recompile the procedure, drop the plan, use crazy hints, etc. Now, with automatic query tuning, we have the ability of telling the engine to automatically adjust that behavior, right? Really, really powerful. And as I said, the automatic index management in Azure SQL Database, you have the possibility of enabling it from the portal directly, right? So here there are some you know, additional information. Consider that, again, this is only for Azure SQL Database, right? Okay, switching to another feature introduced back in 2017, adaptive query processing, right? Historically, when SQL Server compiles a query to come up with a plan, that plan was stored in cache, but it was, you know, something that cannot be changed, right? That means that that was the plan and it's going to be used for, you know, certain time until for some reason it gets recompiled again, whatever. But the plan is static, right? Whether it's good or it's bad, it's going to be that plan, right? With adaptive query processing, Microsoft has introduced some changes on the behavior for the query plan. That means that after executing the query using that particular plan, the engine was providing some feedback saying, maybe we need to adjust this plan this way or this other way. We're going to see it in action and you will love it. Initially, you know, again, the plans are not static anymore. There's going to be some feedback that will allow you to adjust, allow the engine to adjust automatically certain behaviors, right? So initially in 2017, adaptive query processing covered these three cases: batch mode, memory grant feedback, batch mode, adaptive join, and interleaved execution. If we talk about memory feed or memory grants, right? Consider this situation. You come up with a query, you run it for the very first time using you know, any kind of parameter. SQL Server compiles a plan that in that plan it is saying, okay, to run this query you need 10 megabytes of memory, right? So that is coming in the plan. So you say, okay, 10 megabytes is nothing, right? So this is what my plan has. Then that plan in cache, you execute it again, and it's ended up using only 1 megabyte instead of 10. So you are not using 9 megabytes of your execution. Again, we are talking about a few megabytes, not a big deal. But imagine if that particular store procedure is being executed hundreds of times per minute, right? You're going to be wasting a lot of memory, and it's going to be affecting not that query only, it will be affecting the overall server performance, right? And imagine if it is the other way. The plan has 10 megabytes granted, right? But then depending on the parameters that you use, it ended up using 20 megabytes, right? So you know what's going to happen. SQL will come up with the result, but it will spill to 10 dB to be able to fulfill the difference in the memory, right? Okay. What memory grant feedback does is that after executing the query and saying, we are not using this amount of memory, it adjusting the plan on the fly to use the right amount of memory, right? So again, this is extremely useful because it's helping us to accomplish what we just said before, right? To have our workload as stable as possible over time, right? For the adaptive joins is also something important. You have different type of joins when you compile the plan, right? Again, it will compile the plan, it will choose one type of join, for example, has join, right? But with this new adaptive join, there's going to be a new operator that, depending the amount of rows returning from any kind from the tables in the join, it will use one join or the other, right? And that will help you to accomplish a better performance. At the top of adaptive query processing, right, in SQL Server 2019, Microsoft rebranded and added a superset of features called intelligent query processing, right? So in this slide, the boxes that are in regular letters are the features coming from SQL Server 2017, and the ones in bold are the ones coming in SQL Server 2019, right? Beside the one from memory grant feedback, as I said, we're going to see it in action in a few minutes. We have one which is extremely important, which is scalar UDF inlining. We have all been dealing with scalar functions, right? And you know that historically SQL Server is not doing well with scalar tables, because it considers that whatever is coming on the scalar table, it has no weight, right? So you can just run it and it will have absolutely no weight. But in reality, in real life, you can have certain developers that made a lot of logic within those functions, and then this function is used in a select, or even worse, in the predicate under the workloads, right? And even if SQL considers that is very low in terms of weight, it may have a lot of impact. So, we've been dealing with this since forever, right? With this option, scalar UDF inlining, what SQL Server will do is it will try to compile the guts of the scalar function and then embed it into the main plan to have a more, let's say, a real plan instead of something that was not good, because again, it will consider the real weight of the function instead of just consider that it has not. So how do we use this? How do we enable all these features in intelligent query processing? Well, it's quite easy, actually. We only need to set the compatibility level of our user database to either 140 2017 or 150 SQL Server 2019. With that, we have all those features ready for us to be used. Another interesting feature introduced in SQL Server 2019 is the one called lightweight query profiling. Imagine this situation. You are running a store procedure which is running for 40 minutes, right? And you don't know at which point of the execution you are at. You don't know if it is going to finish in a few minutes or if it will take forever to finish. Well, with this feature, lightweight query profiling, you have the ability to have for every single query running on your SQL instance, right, the estimated query progress in percentage, right? So you will see if it is at 10%, 50%, 90% of the execution, and with knowing that, you can take better decisions, right? So I wait a few more minutes until it finishes, or I just kill it or do any other action, right? So this is new, right? Knowing the estimated query progress of every single query on my system. This is really, really good. And as I said, introduced in SQL Server 2019, which is enabled by default. Something interesting that Microsoft has done is allow us to have this feature, lightweight query profiling, back in SQL Server 2017 and 2016 with Service Pack 1. Right? In this case, the feature is not enabled by default. You have to enable it using a global trace flag 7412. But you can have this feature in 17 and 16. We will see it in action in a minute. And finally, the changes that were done on the TempDB, right? You all know that we have to do magic to set up TempDB, the contention, the latches, and come up with TempDB files with the same size, and the number of files has to be same as the processor, all these kind of rules. But even though the TempDB is a precious resource which is unique for the instance, so we really need to take care. In SQL Server 2019, Microsoft has added certain features which were coming from another feature called in-memory OLTP, right, for certain objects of the TempDB, right? So if you enable this feature called TempDB metadata, right, for certain objects, you won't be creating a temporary table in memory, but the metadata for that specific table now is going to memory, and with that you avoid several type of latches, and your workload, if it is TempDB intensive, is going to be much better than what it used to be. So let's see all these features in action. So what I have here is a virtual machine in Azure, right? And I am connected, as you can see here, to 2 managed instances, one SQL Server 2019 running on this virtual machine, and down here I have an Azure SQL database, right? So from here you can see that we can run the demos on any of the 3 options, right? The outcome will be exactly the same. Just wanted to show you that from here I can connect to all of them. So let's start with lightweight query profiling. Right? So what I'm going to do here, first of all, Lee, Anthony, let me know in terms of timing, how long do I have? If I have a few more minutes, you tell me.
So we usually go till about 8:30. So you got about 20 minutes.
Okay, I believe it's enough. So here I have this query. What I will do, I will enable the live query statistics, right, from here, from Management Studio. So I will just enable it, and I will start running my query. The new addition here is that we see, the query progressing here, but the new part that I have is the estimated query progress. So I see here at the top and here at the bottom, right, the progress of my query, right, and here we see the plan, which is live, right. I will cancel this one, and I will run the one below, right? And the case is the same. You see that the estimated query progress is moving on, right? And again, knowing this value, which you see it at the top and at the bottom, right? After some time that the process is running, if it is stuck in few percent, well, you know that maybe you have something wrong with your query, right? But definitely really interesting feature, quite lightweight, right? With like the name is saying, lightweight query profiling. So for every single query on your instance, you will have this estimated query progress. Now you can tell me, okay, this is nice, but I don't run my query through Management Studio, right? I have a web server, an application server. How do I see the estimated query progress or the live query statistic for the queries that are running from my external application? So what I'm gonna do here, I will run something. I have what do I have it here? Random workload. This one will run, several queries against my user database. So this is simulating activity on my user databases. So how do I check the live query statistic as well as the estimated query progress? Well, I go here at the instance level. I choose activity monitor. Right? This is something that we have it since many years ago. Right? It's going to take a few seconds to populate this, right? One of the options that we see is at the bottom, active expensive queries, right? So we see all the queries that are running on my system. If I do right click here, I have the option of show live query execution, right? So that's what I'm gonna do. So here, and with that, I see on a query running from an external application, I see the estimated query progress all the time. So I know at which point of the execution it is at. Right? So really interesting feature. I'm going to close this now. All right. So now we're going to switch to Querystore, right? Here I have created a user database called Querystore demo, right? Basically, it's a database in where I just created, and here, if you can see, I'm setting Querystore off. This is actually for the cases in where it's run on an Azure SQL database, right? Where, as I said, it can enable by default, right? So I'm just disabling it. Then I'm creating a simple table with 3 columns, right? And then a store procedure that basically what it does is going to do a select on this table, right, based on the input parameters. So finally, what I do is I enter a bunch of rows into my table. If I do select from my table, you will see that there are a bunch of rows here. So what I'm going to do right now is enabling Querystore, right? So from this point onward, it's going to start collecting everything. So what I'm going to do now is I will execute my store procedure 20 times, right? So I just execute the store procedure 20 times. When I go to my management studio, to the database, and then I go to Querystore here, I will choose the option top resource consuming queries. So when I hit here, I will see that I have my query ID 1 here, which has this plan, which was represented in this chart, right? We can go to the summary option, and we see here that it was executed 20 times with a minimum duration of 2.6 and a maximum duration of 5.3, right? So what I'm going to do next is I will create a non-clustered index in one of the columns, right? And next, I will execute the same store procedure another 20 times. When I go back to Querystore, I will refresh here. Now we see that my query ID 1, right, now has a new plan, right? We can see the differences between the plans. See here at the bottom, right, the shape is completely different. And if we go and check here, we see that the new execution, another 20 times, the minimum duration was 0.05 and the maximum duration 0.15. So way better than the one that was using before, right? So from now, this just capturing performance data. Going back to the script, what I will do is generate another non-clustered index now covering 2 columns, right? And I will execute the procedure again 30 times. When I go here, we will check. And we see that now we have a third plan because, there is another index, right? You know that the plan can change because of any kind of statistic change or index or whatever, right? So really, those are few of the things that may be the reason for changing the plan. If we go to the summary view here, we see now that the new plan ID is even faster than before, right? Till now, I mean, it's good. We capture the performance information for this, and we have it there. So interesting. We know we have a lot of insight of our workload, right? But eventually what you can do is here decide, okay, for this query ID, I would like that my execution use this plan for any reason, right? So we can go here and check force plan, and manually we decide which plan is going to be using from this point onward because it's being forced by us, right? So let's switch to the next feature, which is automatic query tuning at the top of Querystore, right? Remember, here when you detect the regression, you have to manually go and force it, right? So let's close this one. What we will do now, right? I will show you here. I have my performance monitor with the counter batch requests per second, right? What I will be doing here, I will repro this. I will generate my random workload. We will see that now I have made clear here. So now we have an average of 90 batch requests per second, right? So what I'm going to do right now is I will introduce a regression in the plan, right? So I generate a regression, and you see that now my batch request per second for this query, for the instance, now is back to 15, 20, not what it used to be, right? How do we fix this? Well, from Querystore, we have to go and identify the query and force the plans to use the previous one. So now I will stop this one. Now the batch requests go back to 0. And what we will do is initialize again. What I will do here is run this statement, right? Alter database, set automatic tuning, force last good plan equal on, right? We run this. So of course, Querystore has to be enabled beforehand. Now, what you will see here is I will run again my workload, right? We see batch requests per second, again, going to how it was before, right? And now what I will do is generate this regression again. Please note what is going to happen with performance monitoring. So the regression was generated, right? And see what happened. Without me doing anything, batch requests per second came back to how it was, because it automatically and immediately forced the last known good plan, right? How do we get additional insight from this? There is a dynamic management view called sys.dm/db tuning recommendation, in where we see what it has done, right? Basically, it found that there was a regression, and the CPU time was reduced from 456 milliseconds to 88 milliseconds, right? So this is the script that it applied automatically, which is what we saw before, the SP Querystore force plan, right? So really interesting. You can have this for all the workload running on your user database. Again, this is a demo instance, so you won't see more than that, but definitely something to consider. You see here, there was this regression, and immediately it went back to how it was. So if this happened at 3 a.m. in the morning, when nobody's in front of the Querystore, let's say, dashboard, it's going to be fixed automatically. From my point of view, this is amazing. And by the way, I use it all the time. So this is automatic query tuning. Let's close this. And now let's jump to intelligent query processing, right? We will go to remember, this was when you have feedback on your plans, right, to adjust the behavior. So here, let me just include actual execution plan. What I will be doing here is switching the compatibility level to 150, so SQL Server 2019, and cleaning the procedure cache, right? And what I have here is basically a store procedure which does a bunch of joins. So I will create this. Okay, so what we will be doing next is I will execute the procedure with the parameter 8 for the first time. It's gonna compile the plan, right? So we just executed. It came back empty, right? Nothing. If we go to the execution plan, we see this warning sign. So when we go hit the warning sign, we see that in the message we have here, query memory grant detected, excessive grant. It granted 67,776 KB and it ended up using almost nothing, right? So this is the plan that I have in the cache right now. So I will execute the same procedure again with a different parameter, 9 in this case. When I run it, right, you will see that now it's taking longer. It's going to return certain amount of rows. It's taking several seconds. "16 seconds and 231,000 rows, right? When we go check for the plan, we see that we have these warnings everywhere, right? If we go here, we see the grant. If we go here, we see that the order by was operator used TempDB to spill data during execution, blah, blah, blah. If we go to the hash match, it's also spilled to TempDB, right? So nothing fancy, it's using more memory than it was initially assigned. So remember this number, it took 16 seconds and it returned this amount of row. What I'm gonna do next is I will execute the store procedure again, one more time, right? When I run it for the second time, now instead of 16 seconds, it took 1 second, right? And when we go check for the plan, we see that all the warnings have disappeared. And that is because of the memory grant feedback that was saying, hey, I need more memory, or I'm using more memory than the one that I was granted, right? So you saw the difference. At 16 seconds, now 1 second. And the most important thing, and what is Microsoft trying to focus with all this feature, is without any code change. You don't have to modify your code here in order to make better performance. You see before, we haven't touched any code, right? Just with this feature. So again, amazing, really easy to use, and the benefit, you can see it right away. What else do we have here? Let me close this one. Close this one too. This is adaptive join. Yeah. So again, we will be switching the compatibility level to 150, cleaning the procedure cache, and running a query which has an inner join. I will, of course, select include the plan, right? So now when I go check the plan, see that now we have this new operator called adaptive join, right? So depending on the amount of rows returned from this, from the rows, is going to be using two different types of joins, right? So again, you have to do absolutely nothing. Just this new operator will take care for you. And the new one in SQL Server 2019, Scalar UDF aligning, right? What we have here is, as all the previous demo, just setting the compatibility level, cleaning the procedure cache. What I have here is store procedure, simple store procedure, UFN customer category, that depending on the customer ID, it will come up with one amount. And if this amount has, certain values, you're gonna get the category, which could be regular, gold, or platinum, right? Depending on the amount. This is like a mileage program or something like that. So I'm creating the Scalar function, right? We have to double check something important. It has to be an inlining using function. It cannot be a multi-statement function. So here with this DMB, we can check this column, which is inlineable 1. So just to make sure that this feature is going to work for this function. So pay attention to this. Now I will execute this part of the code, right? And when I'm switching the compatibility level to 130, which is SQL Server 2016. And then, cleaning the procedure cache and doing a select top 10 of this, of the table dimension customer using the function that we just created, right? Of course, I have to select here the execution plan to include the execution plan. So when we go here and we check the execution plan, we have this option here, compute Scalar, right? Compute Scalar, it's also return, like it's going to return 100. So you don't see anything related to the function that we created before. Now I will change the compatibility level to 150, and I will run the very same query that I ran earlier. So when I do this, now I run it. The only difference, again, is the compatibility level. And now check the plan. The plan is much more richer because right now we have the plan for the function embedded here into the main plan, right? So it's not considered that it's, no weight. It's getting the right weight for the query. Really, really impressive, really useful, right? And easy to use. And as I said earlier, Microsoft intention is not to make you change the code in order to make this to run better. Very good. So going back to the presentation here, where we are just finishing, I leave you here a couple of QR codes. Everything new in SQL Server 2019. This link will take you to the official documentation. You will see all the benefits related to performance features, but also the other features like security or high availability. Here, the same for the Azure SQL Fundamental. It will take you to the official documentation, right? And with that, we just finished the presentation. If there are some questions, now's the time.
All right, thanks very much, Javier. Does anybody have any questions for him? We don't have any just sitting in the chat, by the way, but if you think of some, you can ask.
So again, you can ping me after my Twitter, my LinkedIn, if you have any other question. So again, Lee, Anthony, thank you so much for allowing me to present for your community. It was was an honor for me to be here today.
Yeah, absolutely.
Thank you very much.